Welcome to a new feature, a mailbox segment. It may come as a surprise to some that YouTube channel owners do not automatically have the right to reply to people that post comments on their channel. Well, you can, but you need Google+, which I don't have and don't have any need for. Our first question from Robert Adlington was how you actually tie a magnetic loop into a figure 8 and how you actually did that with the metal strip that I used. The answer is you don't need to. Magnetic loops comprise a larger loop which is brought to resonance on the operating frequency with a variable capacitor, either small air-spaced or a vacuum variable, and a smaller loop for coupling the RF signal from the transmitter into the larger loop. There's no DC or physical connection between them. The answer, Robert, is you don't need to. Magnetic loops comprise a large loop resonant on your operating frequency and often a smaller loop which couples the signal from the transmitter into the larger loop. They are not electrically or physically connected. They just need to be near each other for there to be appropriate coupling of the RF between the two loops. And you don't even necessarily need a smaller inner loop because there's other ways of coupling the transmitter to the loop. For instance, a lot of my magnetic loops use what's like a gamma match, just tapping the centre of the coax along the length of the loop from the very bottom. That's around 1/10 of the loop circumference. You need to find the exact point for lowest SWR on all transmitted frequencies. A common question, especially from people overseas, is where do you get things? Especially things like Squid poles, which I use for portable QRP antennas. Unfortunately, I'm not best qualified to answer that. As you can probably tell, I'm in Australia, and where you buy things overseas is something I haven't gone into. And besides, something like a Squid pole, which is worth $40 or $50, will probably cost at least that much to ship from Australia. So, you're better off finding a local source. Just in from Tony, VU7JUL, is what's the most efficient way to learn stuff? Not just book learning, but learning in practice. Tony wanted to get a feel for circuits as to how they really operated. It's a good question, Tony, because RF as it's built doesn't necessarily go to plan as it's described in the book. You can get extra complications like amplifiers not amplifying, or amplifiers oscillating, and oscillators not oscillating. You might build a circuit as per the book, but your particular version might not give any joy at all. Build stuff. Start with something simple and basic, maybe 1 or 2 transistors, just a crystal oscillator and a buffer stage. I've got a YouTube video on that, and just start experimenting, building 1 or 2 stages at a time. And then you'll eventually get to something like a direct conversion receiver, CW transmitter, make it VXO so it's very simple, and then eventually you'll be able to move on to bigger stuff. It's basically just trial and error. Fueled by your success with a simple project, you can then tackle more advanced projects with greater confidence. I've also done videos on the various important RF stages that you need to build a transmitter or receiver. Watch those videos again if you haven't already done so. Start building a few things of each stage and mix and match until you get a variety of receivers and transmitters built. It's also worthwhile to measure stuff, whether it's current or voltages at particular important parts of the circuit. So that's why test equipment like a multimeter, RF power meter, and those sorts of things can be really useful. And you can do huge amounts of stuff on computers. For instance, a simple software-defined radio, even if it's only 1 or 2 transistors, can allow you to see the signal on a computer screen and get an idea as to how it may sound on the air. A couple of guys were interested in my tiny 40-metre rig. That was the little rig built in a food container that fitted in a pocket. From Ozalex Denko asked, which antenna do I use on 40 metres QRP? Well, most of the time it's a half-wave vertical, about 20 metres of wire, not critical, supported as an end-fed. I use a Squid pole extending to about 8 or 9 metres. At the bottom of the antenna is an L-match antenna coupler, which matches the high impedance antenna to the 50 ohms demanded by the transceiver. And by the way, I use a counterpoise usually, just a couple of metres or so of wire, again not critical. Check out a few of my earlier videos for more details. Flame Drag 18 asked how much power was in the crystal earpiece. I don't know. It would only be a few milliwatts, and I haven't measured it. It's not the most sensitive of receivers, but it's good enough for casual operating on 40 metres. As with working DX on such a little rig, it is workable, but a rig where you have to adjust the tuning control to go from transmit to receive is somewhat frustrating. And not to mention the lower power. I think I've had contacts up to about 1,000 or so kilometres with 100 milliwatts. There's no doubt I could work further afield, like into New Zealand or even across to America, but I haven't done it with that low power, at least on 40 metres. For real DX of over 3,000 kilometres, then bands like 20 metres I find are much easier, where contacts into Europe or into the United States are quite possible with even 500 milliwatts on SSB. AMDXing asked about the Onevalve regenerative receiver. That's the one using the 12AU7 powered of 12 volts for both the low and the high tension. He wanted to ask how I powered the LM386 audio amplifier that the receiver uses. Well, it's the same power supply, 12 volts, also powering the LM386. Somewhat on topic was a video I was going to produce called Research Methods. It sounds like a dry and boring topic, but it's really about how to find out stuff you really want to know. My first rule when you want an answer to a question is the multitude is better than the individual. Why ask one person when you can ask a group? How do you harness collective wisdom? The first and most obvious is to use a search engine. Just put in what you want to find out in Google. A problem with that is there's a lot of stuff that's irrelevant, and you need to know the terminology first, otherwise you won't specifically get to the thing that answers your question. And some of the best stuff is not necessarily well indexed, so may not find its way to a search engine. Another thing you can do is to go on various amateur online forums, like EHAM, QRZ, or here in Australia, VK Logger. They are divided into several separate sections, which you might be able to ask a question there for a particular speciality. Your hit rate is better there, because people interested in that specific area are more likely to be looking. If your question is more specialised, you can delve deeper into email or Yahoo groups. They might be to do with a very specific topic. For instance, magnetic loop antennas, QRP, RF design, microwaves, or even a specific model of transceiver. They're even better because the experts you really want to tap are probably floating around there. One cardinal rule though is do a search and see if other people have asked the question before you. If not, then you might want to ask a question. It's a good idea in your question to get a better response rate to actually mention in a couple of lines what you've done previously to find out, i.e. Google might have returned a blank, or you've searched the archives of the forum and not found anything that answered directly your question. Just to prove that you've actually put a bit of effort into it and not just someone who's taking the lazy way out. I know it sounds harsh, but that's how some cranky but knowledgeable people may think, and it's their brains you need to tap to get a good answer often. Now, when you are sifting through stuff, you do need to analyse its quality, because stuff in amateur radio can be written by anyone from a NASA engineer to an uneducated guy like me. So you need to be discriminating in what you read and even what you see on YouTube videos. You also need to think about the other person's position. Like, if they built a magnetic loop, was it designed for absolutely top performance or something that was small enough to fit into a case? Depending on what you want to do, the answers may be different. For instance, the very compact magnetic loop may be highly compromised and not be acceptable for what you want to achieve. On the other hand, a perfectionist who went to a lot of time and trouble and effort may not have a project that's suitable for you as a beginner as something to tackle first. If you like this segment, leave your comments in the box below. Unfortunately, I can't respond to them there, although I may make your question a topic in a future segment.